Modern smartwatches have become incredibly intelligent companions. They count your steps, track your sleep, analyze your workouts, and even alert you when your heart rate becomes unusual. But one question stands out above all others. How does your smartwatch know your heart rate? How does a small device on your wrist measure something happening deep inside your body with such precision? To understand this, we need to explore a technology called plethysmography, often shortened to PPG. It sounds complicated, but the idea behind it is beautifully simple. Your smartwatch uses light to measure your pulse. Yes, light. Your heart rate is calculated by shining light into your skin and reading how your blood absorbs or reflects that light. Every time your heart beats, it pushes blood throughout your body. With each beat, the volume of blood in your wrist increases slightly, causing changes in how much light your skin absorbs. Your smartwatch takes advantage of this natural rhythm. Most watches use green LED lights because blood absorbs green light strongly. The watch shines these lights into your wrist, and tiny optical sensors measure the amount of light that reflects back. When your heart beats, more blood flows through the vessels. Because blood absorbs more green light, the amount of reflected light decreases. Between beats, the blood volume drops and the reflection increases. By measuring these tiny changes hundreds of times each second, your smartwatch converts them into a precise reading of your heart rate. But the technology does not stop there. Movement can affect accuracy. When you walk, run, exercise, or move your hands quickly, the readings can become noisy or irregular. To fix this, watches use advanced algorithms and motion sensors like accelerometers and gyroscopes. These components work together to filter out irrelevant signals and focus only on the pulse. Some premium watches also use infrared light for low power measurements, especially during sleep. Infrared penetrates deeper into the skin and works well in low light conditions, making the data smoother and more consistent at night. In addition to PPG, a few smartwatches offer electrocardiogram or ECG functionality. Unlike light-based sensors, ECG measures the electrical signals your heart produces when it beats. This method is highly accurate and can detect irregularities such as atrial fibrillation. To record an ECG, you place your finger on a metal electrode built into the watch. In that moment, your body completes a circuit. The watch then reads the tiny electrical impulses running through your heart. When PPG and ECG are combined, smartwatches gain a complete picture of your cardiovascular health. They can monitor resting heart rate, detect abnormal spikes, track recovery times, measure heart rate variability, and even warn you when something does not seem right. But smartwatches do not know your heart rate instantly. They use a process known as signal processing, which involves analyzing wave patterns to determine which signals belong to your pulse, and which belong to motion noise, temperature changes, or random disturbances. Artificial intelligence and machine learning models also help, especially during workouts, by predicting and correcting potential errors in real time. It is incredible when you think about it. A device small enough to fit on your wrist uses light sensors, mathematics, and advanced software to study your heart, something that once required expensive medical equipment. Smartwatches are not perfect. They can be affected by skin tone, tattoos, sweat, temperature, and how tightly the watch sits on your wrist. But overall, they offer an impressive and reliable way to monitor your cardiovascular activity throughout the day. So the next time your smartwatch tells you how fast your heart is beating, remember what is happening behind the scenes. A beam of light, a pulse of blood, a sensor reading microscopic changes. and a powerful processor turning those signals into meaningful insights. It is a reminder of how far technology has come and how closely it connects us with our own bodies.